live. All right, awesome. Hey folks, welcome to our second talk for the PyTorch Expert Exchange series. Today we have Hamish Ivison from AI to University Washington Lab, who will be talking about adapting open source models with Open-Instruct and Tulu. So if you're tuning in live on the YouTube channel, please feel free to ask questions in using the chat feature, and we'll take those questions after the talk. With that, I want to hand it off to Hamish. Feel free to go from here.
Cool. Thank you for the intro. So hi, I'm Hamish. I'm a PhD student at UW. I also work part-time at AI2. I'm going to talk about sort of Open-Instruct and Tulu, which are sort of two efforts going on, interlinked efforts going on at AI2 mainly, but also with a lot of UW folks involved. Specifically, I'll sort of talk about touch on Open-Instruct and touch on Tulu 1 through 3, which are sort of a series of models that we've been building. I'll explain more about what those are in a bit. And hopefully sort of cover what like building a modern post-training pipeline or adaptation pipeline for language models looks like. What are the sort of components of such a pipeline, and touch a little bit on sort of how those needs differ to needs in pre-training when you sort of want to do pre-training of language models. Some like quick disclaimers. There's sorts of like some AI2 specific integrations that influence some of the design decisions and stuff for this, so don't worry. Like that meant that we made some of the choices that we did. There's also like, I'm going to be talking about Open-Instruct, which is one particular sort of repository for fine-tuning, but there's lots of other great ones. TorchTune, TRL, Axolotl are all sort of like well supported and support, I think, pretty similar features to us, although in like slightly different ways. And I'm probably going to remain a little bit higher level, but I'm happy to like answer questions getting into like much finer details, especially towards the end. Cool. But first, before I like get into like Open-Instruct and Tulu, like why do we care about language model adaptation in the first place? And what is it? Typically, in the past, language model adaptation has looked mostly like instruction tuning. So we take a bunch of inputs that have sort of instructions of like what we want the model to do, and then some like query, train the model to output the answer. And if we do this over a whole bunch of tasks, turns out the model can sort of generalize to new tasks that it hasn't seen before, as well as sort of like adapt it to sort of like be a bit more like a chat interface or something that looks more like a chat GPT or Claude that a lot of people use nowadays. More recently, in the sort of past like 1 or 2-ish years, this adaptation pipeline has gone a lot more complicated with things like RLHF. There's lots of like people doing stuff like synthetic data, whether you do some rejection sampling as well. Often people sort of do multiple rounds of like data annotation and iterations. And so I think like nowadays there's sorts of a lot of moving parts and things that you want to be able to do when you adapt models. And I'll sort of get to that. And what adapting models lets us do is basically lets us use them in a way that we prefer. So if I go and ask llama 3.1, what is 2 plus 2? The output I get from the base model is some talk about roofing contractors, and it doesn't actually answer the question. But if I go and use the instruct version, which is the sort of adapted variant, then it just sort of plainly gives me the answer, which is what I'm looking for. Similarly, adapting models, partly because of this ease of use and also for other reasons, sort of lets us get more performance out of these models. So if I take llama 2.7b and I do some instruction tuning on it, then its performance can reach almost the level of sort of llama 2.13b out of the box. And likewise, if I then instruction tune llama 2.13b, it also improves significantly. And this is sort of like generally the case across like all sorts of model sizes and different model families. At AI2, the sort of main repository that we use for doing all this sort of adaptation, like instruction tuning, RLHF training, and so on, is called Open-Instruct. It's a public repo. We work on it in public. It's permissively licensed. And so, you can go and look at it now if you want to. And the primary output of this model is a sort of model series that we call Tulu. The aim of Tulu is to sort of combine existing open resources to build a like open, reproducible, general purpose model. So we take good base models that exist out there, and try to work out strong recipes for building sort of general purpose models that behave similarly to what you might see in industry, coming out of industry labs or industry products. But we share all the details. We share exactly what data we use. We share what hyperparameters we use. We share exactly what code we used. The reason the model's called Tülu is because it's sort of a child of many camelids. We started this work originally when sort of like the first llama models and sort of like the first sort of wave of instruction-tuned llama models came out, when we were trying to work out, from how we could combine all these different data sets that were coming out into like a sort of strong baseline for then doing further research on top of. If you're particularly curious, the Tülu series is sort of captured in these series of papers. I'll be touching on them a bit as I go, but I also recommend you go and read them if you want sort of more details and sort of really to get in depth of what we did for these models. So to get to the sort of core of this talk, I want to talk about like how the Tülu series of models has improved over time and how we've sort of changed Open-Instruct and sort of how Open-Instruct has supported that. And the sort of first big thing, perhaps not too surprising, is basically just like doing lots of data mixing and improving our data mixtures. So when we started Tülu, the first sort of Tülu project was basically we just took the llama models, llama 1 at the time, that were available, and then collated a set of like instruction data sets that we thought were interesting and covered sort of a varied sorts of types of data. So like synthetic data, human annotated data, sort of more traditional NLP data sets, etc. And wanted to sort of, see how well they did. And to sort of like take a chart from our original paper here, maybe this is somewhat obvious, but different data sets were particularly good at particular things. So like coding data sets were, better for coding, and your more sort of synthetic chat oriented data sets did better for chat, and so on. However, if you were slightly careful about the mixing the data together and balancing your sort of data sources reasonably well, you could then make a data mixture that sort of captured most of the benefits of training on any one particular data set without getting the downside. So this sort of bottom row down here is sort of doing the best on average, and generally speaking is always improving over the base model. In terms of how this looked like behind the scenes, originally it was we had basically some fine-tuned scripts that let us like submit sweeps across different dataset files on some AI2 internal compute. Once that was done, we'd then run some eval script that automatically kicked off a set of evals that we would then sit down and sort of manually annotate into a spreadsheet, which I've captured on the right here. This spreadsheet goes for like thousands of rows, and there's a lot more results in here. I think we had to retire at some point because it was just kind of too slow to load, and we were pushing Google Sheets a bit too much. Nowadays, we've sort of improved this experience a bit in Open-Instruct. One particular big thing that we've done is allowed sort of data mixing directly in config. So relying a little bit on Hugging Face data sets as well as some AI2 stuff, you can basically define exactly how, what data sets you want to load, how many examples you want to load them in, or alternatively, like what percentage of data you want to load in, submit a training script that automatically runs, that then automatically kicks off a set of evals that then gets uploaded into an internal leaderboard that we have. This means that basically all a researcher has to do is sort of make some data that they think is interesting, and then they can kick off a job, and then the training, the evaluation, and the comparisons are all sort of like automated to some degree. They can, once within sort of, usually for smaller models, these jobs take training takes like within a day. So sort of within 24 hours, you can go from an idea with a data set to sort of a final eval result and comparisons in fair settings with other models that you've tested. This is also nice because it allows us to track our sort of data mixtures in Git, which is a little bit more principled than using a really big Google spreadsheet. And so that's sort of like the first thing. It's maybe, I think like having easy data mixing and making it easier and easier to sort of just randomly try out incorporating new data and updating our data mix over time is really important. And so to sort of like highlight this, here's I'm going to sort of like track the performance of this model over this talk. So if we take Llama 3 8B base and we train it on the Tülu 2 mixture, which is a mixture that we came up with in November of last year and evaluate it across a sort of set of evals, we get roughly 50% performance. If we just took some time to update that mixture with some recent data sets that have come out, we can sort of bump that up to 53% without sort of doing, without sort of doing too much extra work, right? No new fine-tuning techniques or anything, just sort of trying out some new data sets that have come out and are publicly available. The next sort of thing that I also sort of already touched on is sort of supporting varied evaluations. So if I go back to this sort of table that I showed before, like an important thing that something that was really important to us is that we were evaluating these models on a pretty reasonable suite of evals that covered capabilities that we cared about. So we cared about how well they were doing at like math and reasoning. We cared about multilingual performance. We cared about coding, and we cared about sort of like chattiness type abilities with Alpaca eval. Since then, we've sort of expanded the amount of evals that are available in Open-Instruct, and we've tried to keep the ability to add evals sort of as light as possible. Evaluations basically are like a Python script that sit in a folder, maybe there's some light shared utilities to make things like, calling a generation loop much easier, for example. And this allows us to sort of have lots of different types of evals in there. There are evals that are using LLM as judge setups. There are evals that are sort of measuring parse at K across multiple generations. There's evaluations that are using classifier models trained to be classifiers as judges. That's really useful, for example, in doing toxicity evaluation. There's also more standard multiple choice evaluations. And this has been really important, and also like traditionally kind of a sticky issue with some of the pre-training folks, where often the type of evaluations that we care about in the adaptation side are a lot more freeform and a lot more about getting models to sort of generate long bits of text and then evaluating them either with other models or in some other structured way, rather than these sorts of the more sort of multiple choice or ranked choice type tasks that you see in pre-training. We've also, as I said, got this sort of like leaderboard that we continuously add and update the evaluations. And nowadays we also sort of like track model metadata such that it's easy to, if we want to add an eval, rerun all of our existing models on that new eval to get comparisons. Or if we find a bug or a new prompting setup for an eval that we think is better, we can then swap that in and update the leaderboard. There's also lots of fun filtering options and stuff. And I know recently a lot of people with Turlia AI2 have probably spent a lot of time sort of just like sitting with this leaderboard open and poking at it to get ideas of what data sets have worked particularly well for what evals or what sets of evals. And I think like it's really important to cover a broad spectrum of evals, because a lot of these evals are either like particularly narrow, like obviously GSM is only covering math, but even the sort of more broader evals can be biased in weird ways. So when we were working on the Tülu 1 models, for example, we found that Alpaca eval 1 had a very striking sort of length bias. If you plot the sort of win rate of Alpaca 1 and the average output length of a given model, it forms almost a disturbingly straight line. This has been somewhat fixed with Alpaca eval 2 to some degree, but it actually kind of still exists a bit, I've found. However, even if we did get humans to sit down and judge our model outputs, humans themselves can be biased in all sorts of interesting ways. I like this sort of example where this paper sort of suggests that humans find more assertive model outputs to be higher quality. And maybe you care about this. Like this might be good if you just want your model to sort of sound good to a person. But if you care about the actual sort of reasoning or reasoning capabilities of your model, or the sort of like factual knowledge capabilities of your model, then I think it's really important to include and design evaluations that are specifically targeting those. Likewise, if you only look at one particular evaluation, it can paint a misleading picture of how well your model's going. So for some recent work, we looked at training the Tülu series of models with PPO. And we found that as we train the models for longer with PPO, so that's the sort of x-axis here is the number of PPO steps, they continue to just improve on Alpaca eval 2. Alpaca eval 2 just kept going up until we stopped training eventually. However, the model got just worse at most of the other evaluations present. So it's instruction following score if eval score dropped, and it's a GSM grade school math score also continued to drop. And so this is like a sort of another reason why we sort of care about like continuously expanding the scope of our evals and swapping in new evals where we can in order to get sort of like a good idea of how well our model is doing as a generalist model, as opposed to just as sort of like a chat assistant or just as sort of a math model and so on. So considering wider varieties of evals and making it easy to sort of just add more or update existing ones where possible. And there are some evals that we're tracking particularly a lot right now. If I go back to sort of the table I had before, two evals that I kind of have been very interesting for me to track are sort of math, which is harder math problems, and Alpaca eval 2, which I've also talked about a bit. And here you can sort of see that, again, we balanced our data mixtures and we got some improvements. And we're sort of like, when we're designing our data mixtures, sometimes we decide to target one or two of these evals in particular, like trying to gather math data to see if it improves our math scores and so on. But I've been talking a lot about just like data and evals right now. I haven't been talking about the sort of some stuff that I mentioned earlier, which is sort of preference learning and RLHF, the sort of entire center of this big chart that I showed earlier. And adding sort of preference learning has been, and RLHF in general has been, we have been working on this, adding these to Open-Instruct in a variety of ways. We started by just looking mainly at DPO and PPO. If you're not aware of what these methods are, PPO is basically an online sort of RLHF in general, works by training a reward model on human preference data, and then training your language model to try and produce outputs that get high reward in some sort of RL loop. DPO and a sort of range of our direct alignment algorithms instead just sort of train your model directly on that data using a variety of different methods. Adding sort of DPO or PPO into your pipeline usually results in improved performance, especially if you care about things like Alpaca eval or toxicity. So when we added it we added DPO for the first time in the Tülu 2 mix, to the Tülu 2 models, and we saw really big gains in Alpaca eval. We, on average, like the models did improve a bit, apart from the largest, although this is kind of due to multilingual performance dropping. We didn't train on multilingual preference data, so this is a likely reason why. And sort of since then, there's been like a veritable explosion of DPO-esque algorithms out there that all claim to be really good in one way or another. Here's sort of like a non-exhaustive list of these from the recent Simpio paper. And I think there's sort of more coming out all the time. And in Open-Instruct, we've added a bunch of these. We have DPO as well as a length normalized version. We've added SymPO and WPO. We've added some code for rejection sampling. And we have, I don't know if the PR is merged yet. It should be merged this week, sort of online training as well with PPO and online DPO. So there's sorts of, if you start with an instruction tuned model, there's all these sorts of different preference learning methods that you can try out for your post-training. And this has been really important for improving certain evaluations is sort of like the third thing. So if I sort of go back to, and one other thing that I forgot to note is that often we also, currently, I don't think we have a script committed, but we've also found merging these models to be particularly effective as well. So sort of taking, say, a DPO trained model and a model trained on some particular data set and merging the two to get a sort of combination of the abilities. So if I go back to this sort of chart over here, we improved our data mixture a bit, and this improved performance a bit. We wanted to get better math performance. So we actually trained a model on a math-specific mix and then just merged it with the original model. And this boosted our math scores by quite a bit and overall improved performance a little. And then we did some additional DPO training, and this really boosted Alpaca eval 2 while not dropping like performance elsewhere too much, and so resulting in sort of overall an improved model. So to give you like an idea to sort of graphically lay this out, we sort of started with Llama 3, we trained it on this Tülu preview mix. We then trained a math-specific model, merged the two, got an overall better performing model, and then did DPO to further improve it. And this is honestly a kind of like more simple model lineage of some of the models we've been training internally recently. I've seen cases where we've trained some model and some data, then DPO'd it, then merged it. then trained on some more data, and then DPO'd it again. And I think sort of embracing this chaos has been quite important to work out what methods work particularly well and sort of hill climbing on the evaluations that we have. So if I go back to this, we've sort of now internally reached a point where we're sort of roughly at the level of Llama 3.0 instruct with a good recipe, and we have a bit more to go with evals like math and so on, which we're working quite hard on. Cool. I'm just going to quickly skip over this. But I'll also note that oftentimes with these especially with these online training methods, we often see that generation times are the real bottleneck. And so making smart use of libraries like VLLM has been really important in keeping our sort of PPO training times down, as well as generating synthetic data from larger models as well. And finally, I'm just going to quickly talk a little bit about going beyond Tulu. So the Open-Instruct codebase is used at AI2 not just for Tulu, it's also used for fine-tuning the OMO models. Most recently, it was used for the OMOE model, which is a very cool MOE that Nicholas just put out. There's a few fine-tuning results in there that were trained with Open-Instruct, and you can go try out that model. We also find it useful to be able to take base models that other teams have put out, integrate it into our pipeline, in order to sort of compare how well other teams' instruction and adaptation pipelines are to the recipes that we've been developing. And so this is sort of a final thing that's really important for AI2, is that we really want Open-Instruct to also be flexible across sort of varied model families. I would probably say overall, we sort of lean a lot more towards flexibility than speed or optimization. Our data sets are much, much smaller than pre-training data sets. We have a much bigger sort of bag of methods that we like to use with all these preference learning methods and rejection sampling and so on. And so we always sort of lean towards flexibility over like optimizing stuff particularly hard. So like we're trying to, of course, like this isn't the end for Open-Instruct. We're trying a lot of new things, a lot more things. We're sort of trying to get more and more into online training. So further developing the sort of PPO and online DPO toolkits with things like process reward models and so on. We've also been looking at like trying to make sure that we're not hill climbing by just including our test data accidentally, which could happen when you do a lot of data mixing. There are some popular data sets that have crazy high alpaca eval contamination out there. Check your data. As well as thinking about like data filtering techniques in general, how can we isolate cases where there might actually be good data, but it's wrapped in a data set that has a lot of other useless or noisy data, as well as a ton of other stuff. And yeah, thanks for listening. I'd like to especially shout out Yizhong Wang and Hannah, who Yizhong worked as sort of was my primary first author on most of this work. And Hannah is my PhD advisor, who's also advised all of this stuff and has been really helpful. And if you're interested in the code, there's a sort of QR code up here and a sort of link. And feel free to reach out on X or email, or if you're interested in some of these works, you can probably find them on my website. Yeah, and that's about it. Thanks.
Awesome. Thanks a lot, Hamish. That was a really interesting talk and great to see how Open-Instruct has progressed over time for like post-training optimizations of the LLMs. I guess like I had like one very high level question, since we have a lot of members here from the PyTorch team. I'm curious about like how you use, like what features of PyTorch you really find valuable, and what, if anything, you think PyTorch could do better to support your research.
Yeah, I think so we lean a lot on like a lot of like various open source libraries or codebases out there, like Hugging Face, PyTorch. We lean on quite a lot. I think like, as I was saying, especially in sort of like with these like online trainers and like very flexible options, I think the ability to sort of like have something that looks like a self-contained little script that you can very easily jump into and debug and hack on is like super useful. We did do some like PPO experiments in like other sort of more JIT frameworks like Jackson stuff, and debugging these was always like way more painful than say like in a simple PyTorch loop or something like that, which is nice sort of dynamic computation graph stuff. The other thing I feel like probably we actually might like look more closely at TorchTune and stuff in the future. We've been one thing is that like we've been relying a lot on deep speed mainly for like getting up to larger scale, like training larger models at really large scales. But I think there's been a lot of like very nice features that have been added into PyTorch recently for sort of improving scalability here that hopefully we can kind of integrate. One thing is that, like, as I sort of mentioned, we'd like to not tie ourselves too tightly to any particular model architecture choice, because it's nice to be able to take, you know, a model that sort of like someone has just put out and like quickly try it out, put it through our pipeline and stuff like this. But at the same time, there are also models that we lean on quite heavily, like the Llama series, for example, where it does sort of make sense to try and like potentially to optimize that a bit more. Yeah.
Thanks so much, Hamish, for a really interesting talk. So I maybe wanted to piggyback on what Supriya was asking and sort of like your response there. I was curious about how you think about sort of building on top of other libraries with the ecosystem, not just for fine tuning. I saw there's a lot of like really interesting code around evaluations that you have, as well as quantization. And so I was curious about sort of like if you could talk us through what that like development process looks like if a new paper comes out. And it's really exciting because like a lot of what you talked about is exactly like how we think about TorchTune, Torch.io, and some of the libraries we've been developing, like hackability over everything else. So yeah, I'd love to sort of learn more about like what does that development process look like.
Yeah, that's a great question. So I think like often it can like depend a bit, I guess. I think like usually, ideally, if we want to integrate, like let's say like there's a new preference learning method or something. Ideally, we want to sort of like, usually in the past we've taken something like one of our, so for some of the methods it's very easy to sort of add. So especially with these like DPoS methods, because it's kind of just like a slightly different data processing pipeline because you're dealing with preference data now, and then a slightly different loss function. And so often I'll sort of start with our existing like fine-tuning loop, our existing training loop, and then look at like the open source code base of, in this case, I think in DPO's case, I literally just went to like looked at the DPO implementation. And like I think we're very happy to sort of like copy stuff in when it makes sense. For evaluations, this is sort of what we try to do, is we like it's preferable if we can to sort of like copy in the sort of core logic of what's going on, and then sort of add the sort of integrations and other bits on top of that. And, you know, give credit where possible, where, you know, give credit where we've like, you know, copied particular bits of code over and so on. In some cases, like some evals have like pretty nice packages that we can use. So like our pack eval has like a pretty nice package that makes it very easy to just put into sort of like an inference script. But in other cases, like I think for math or truthful QA, we've sort of like leaned more towards like going to the original implementation, copying some stuff over, and like thinking about some of the defaults and whether they make sense for us as well. And yeah, really, I think a lot of it is like the design structure is ideally try to be closer to like, sort of like a collection of scripts with shared utilities where it sort of makes sense, but are really sort of designed to be more or less self-contained, so that, you know, if something new does come along, it's very easy to either take some code that's already been out there for that method, or, you know, take one of our existing scripts and change the core bits that make sense. I like those are the sort of two basic approaches. And then, you know, commit it up in sort of a new script. Yeah.
Yeah, thanks, Hamish, for the talk. It was very interesting. I think one question I have is like, given that you work with this kind of whole pipeline of like the whole post-training world, right? Like fine-tuning, alignment, eval, quantization. Like, do you find that there are certain areas that are like not really that well served right now, or where you have like more friction than you would like to have, and you have to hack around stuff more than you would in an ideal world?
Oh yeah, that's a really good question. I feel like I would probably say like distributed training always feels more painful than it has to be. Like it would be really nice if we could always just scale, like if we could just hit a scale button and use like jump straight from like one or two GPUs to multi-node. And to be fair, it is pretty like it's not too bad right now for us in this repo, but there's often there ends up being sort of weird. So like often it takes like a bit more time than would necessarily like. The other thing I feel like is that sometimes it can be a bit annoying to sort of swap between. So I mentioned before that like oftentimes like generation is like a big bottleneck in say online training, and swapping between like often what you want to do is something like, okay, when I generate, I want to like load up a VLM engine, generate a ton of like online examples, but then I want to swap back to my regular sort of PyTorch forward back loop for then like doing some, taking some PPO steps on that. And this often involves like, you have to be like, okay, I'm going to put like my inference is always going to sit on like this GPU. Like you have to do some manual GPU memory management. You have to sort of deal with the fact that sometimes you are dealing with like not really conflicting, but you're dealing with like multiple systems of managing your models. And this can sometimes mean that you have to hack around things, and it's very much not super duper seamless. I feel like, yeah.
I also observed that you have sort of, I wouldn't say complex, but like you do think a lot about like data access patterns and just like mixing different data sets. I'm assuming there's some online sampling involved and so on, and like combining data sets. How easy or hard has that part of the stack been? Like we've gotten a ton of feedback on just like data set abstractions, and especially as we move towards more modalities, it's starting to become like a real challenge. I was curious like if you could talk a little bit about that part of the pipeline.
Yeah, I think like data is honestly like data mixing is like a really, honestly, it's always like kind of feels pretty reasonable and straightforward. We haven't done too much multimodality stuff quite yet, but at least in Open-Instruct. And this is probably something we'll move a bit to at start looking at a bit in the future. But I feel like often these days it feels like like firstly the community has sort of like settled on some pretty reasonable ways of like storing your data, and it's pretty easy usually to write some like quick data transform text data into particular forms if you need to. And so I think if anything, we spent a lot of time earlier this year trying out a lot of like fancy preference learning algorithms and like really trying to like dig into say like PPO and what are the best ways to try and get it to work. But then going back and just being like, okay, what new data sets have come out? Can we just like add them to our mix, do some quick ablations, gave us like instantly way more bang for our buck than tried like a trillion new sort of preference learning methods did in terms of like improving performance on a lot of the downstream evaluations that we cared about. So I feel like honestly, data mixing it's not too bad right now. I imagine with multimodal stuff it'll get more complicated. But a really big thing that maybe I think there's a lot of interesting research questions and also maybe some infrastructure questions is sort of data curation, is working out, okay, I can go and download everything on Hugging Face, but downloading everything on Hugging Face isn't going to be going to give me a good model, right? I need to you can do a sort of like basic like grad student approach, or like a budget hire or bunch of research ideas approach of like, okay, everyone go train a bunch of models on these data sets and we'll report our results and we'll look at them and then we'll decide on a mix. And this works very well. It's a very good baseline. But I think there's lots of interesting future work and lots of ongoing work as well going on in sort of like, how do you identify what high quality data points are ahead of time? How do you filter out sort of noisy data? How do you perhaps even just generate your own data ahead of time? Not ahead of time, like regenerate your own data if like a new better model comes out and you want to sort of take advantage of that in some way. And so I think like the basics of data mixing and stuff seem like pretty set at this point, but I think there's a lot in the sort of realm of data curation and working out data valuation / attribution that's really interesting.
Right. It looks like we have a couple of questions on the live stream. I'm just going to read it here. The first question is this something like InstructLab from Red Hat and IBM Research?
I'm not like 100% familiar with InstructLab. I think like there's a lot of stuff out there that is pretty similar. Like I mentioned, like TorchTune has a bunch of great scripts for like training various models. Likewise, there's TRL and from Hugging Face and Axolotl, which I know is quite popular in the open source community as well. I think like Open-Instruct, we started it like a year and a half ago ish, when a lot of these like repositories were kind of still getting started to some degree. So we're sort of like developing it in concert with a lot of these things, and it's more of a it sort of serves like it serves research projects, and then also like the sort of OMO effort at AI2 first, and sort of other things second, which might be different to other stuff out there. But yeah, so from a quick glance, it seems like vaguely familiar, and I think that there are a lot of like frameworks out there that overlap. I think ultimately, it makes sense to just work with what you know, right? And like what you can build easily on top of. Like all these discussions about hackability before. What matters a lot more is being able to have an idea, implement it, and run and test it as quickly as possible, as opposed to nice abstractions and so on. Cool. Should I just ask the question, or do you want to read it out?
Sure, you can go ahead and answer it.
Yeah, data mixing and model merging, and like the trade-offs between them are really interesting. So we found, for example, like I talked about this model earlier, where we trained this math-specific model and then merged it back in order to improve our math performance. We actually did this partly because we found that there was negative interference occurring between that particular math data set that we knew was really good and really valuable, the Numina data set, and the other data we were using. So what we ended up doing, like we ended up trying model merging, and it worked like surprisingly well. We didn't have these negative interference issues, and on average the sort of model improved. So what I'm sort of like thinking that I have some like internal projects that are also sort of starting to point at this, is that there are cases where just sort of mixing your data sets together might result in some sort of interference. Sometimes they're in different format. It might be because they're in different formats. It might be because maybe you haven't balanced stuff quite well. And instead of like trying to perfect your mix, instead just like training separate models and then merging them back together can sometimes just be a much simpler and much more effective way of controlling that sort of like doing that sort of like capabilities mixing, rather than trying to create this big one singular data set that you're using. I'll also note that like sometimes model merging can be a good way to sort of test out how like particular capability, or like test out sort of model ablations and get a good final model without sort of having to do a sort of big training run on one finalized mix. You can sort of train a bunch of models on a bunch of different data sets, check how they go, pick the best ones, and then merge them, and you don't have to do any additional training. And I think like this is sort of going on in like the open source community to some degree, right? Of like people trying out different mergers and so on. So I think it's a really interesting question. There's like perhaps like interesting like unsolved questions about when it might be better to merge versus when it might be better to combine data sets, and we're still sort of working that out to some extent.
I guess I have one more question for you. So you talk about like, oh, actually, let's let the, I already got my turn. Let's let this one go.
This one. I feel like this is maybe better for the PyTorch folks to answer.
Yeah, so this is, I think in short, it would be useful to learn PyTorch if you want to work on machine learning and deep learning. I'm not quite sure because the question seems a little incomplete, but yeah, feel free to check out PyTorch. We have a lot of like documentation resources available online, and you can always like reach out to us via GitHub if you have specific questions. Yeah, Evan, go ahead.
Yeah, my question was, so you talk a lot about like ease of experimentation, and that's one way that you can kind of like, increase the rate that you can get new models out there, like run your training loop. But like the other way that we can increase the rate of experimentation is just make the fine-tuning loops run faster. Like, how important is that to you in your day-to-day experience?
Yeah, this is also a good question. I think like often the scale of these data sets and the scale of the like training runs that we're doing is often quite smaller than say like pre-training level runs. And often like say for like a lot of the data sets that we have, if we want to train like a 8B model and like something like 1 million instruction samples, it takes like 1 or 2 days on the current sort of hardware that we have. I think on like one node of like I can't remember if it's A100s or H100s that we got that number off. But anyway, and so like I feel like it's always good to get your fine-tuning loop faster for sure. And I'll happily take free like fine-tuning sort of wins. But at the same time, I think often the sort of like the actual sort of tokens per second, like the size of the stuff that we're dealing with is not quite large enough that like, you know, a really big reduction in tokens per second would make as much of a difference as doing some of the other sort of quality of life type stuff. If I cut down my like fine-tuning loop from 12 hours to 6 hours, that's great. But to some degree, I think being able to sort of one-click run 15 different evaluations and have that sort of run and then like reported in one easy place is actually kind of more valuable than that like double speed up in trading time, because running a bunch of those evaluations yourself and building out that sort of stuff and doing that a lot of that stuff manually would just be probably more annoying and use up more of your time. And what a lot of people on the team end up doing is they'll sort of kick off. They might have, you know, 6 or 7 different you know, data sets or sweeps that they want to run, and they can sort of kick those off and they'll finish overnight, and then they can sort of come in the morning and all the evals are sort of sitting there and so on, and we can discuss whether or not it's worth you know, what the sort of next action step from those experiments will be. I think also, like, generally speaking, we also sort of like want to, when it comes to things like evals and models, there's always sort of new ones coming out, and we always want to be able to add those. And sometimes like overly engineering well, overly is maybe a strong word, but like focusing a lot on like making stuff faster can sometimes lock you into particular choices that might harm you later down the line when it comes to trying to integrate other code bases or integrate other setups that you might care about.
Awesome. Any other questions?
Yes.
Oh, sorry, go ahead.
I had a quick question on, so you mentioned data set curation and understanding what data sets are high value. I'm curious about if you know how well explored this area is. Are you guys using tools in the community to help you understand this, or is this really just a manual process for you?
Yeah. Originally, it was all very like for a good while, it has been mainly pretty manual in the sense of like running ablations and looking at the results and making decisions based off that. More recently, we've tried to integrate some like more useful things, and we're like, this is all very much work in progress. So we've found, for example, that I mentioned this before, that doing things like regeneration with existing models out there has proven to be like a really good way to sort of firstly improve the quality of your data, but also turns out these models pick up cases like, oh, this question is weird, or like this question is malformed. And you can sort of pick out weird data points in your existing data sets. Likewise, doing sort of rejection, like it turns out in our rejection sampling pipelines, we also sometimes surface this where reward models, like we'll find some data points that have like sort of outlier scores given to them by our reward models, and this usually points to some sort of curation. But we're still sort of, I think, we're like working on building sort of more dedicated methods and tools for either doing like a sort of filtering type thing, or doing a sort of more nuanced data mixing type thing where, you know, you might say like, okay, here's the evals I care about, here's the data sets I have available, how do I construct like a really good mix based off this. And I'd probably say that this is like currently a sort of a very, I think, active research direction in the sense of you see lots of current work on like how to work out good pre-training data. Likewise, I think there's like a good space for like how to work out what really good instruction data, how to like mine really good instruction data from existing data sets out there. So I think it's like, there are some basic approaches that we've done right now. I think it's mostly manual. And I think the manual baseline is also really hard to like automate away to some degree, right? Like it's very hard to beat sort of sitting down and just looking at results and thinking about them and then going on from there. Yeah.
Okay. So I think the answer to that one is unknown at this point, and it's not really relevant to the topic of discussion. So yeah, maybe if you have a question about it, might be worth using the discussion forums or creating an issue. All right. Any other questions from folks in the room or comments? Cool. Yeah, I think that concludes today's session. Thanks a lot, Hamish. Thanks for your time again. And this was really insightful for us to learn as PyTorch developers and I guess as users as well on how some of the research in this space is evolving. All right. Cool. Thanks, everyone. And I guess we'll see you all at the next one.
Cool.
Bye.
Thanks for having me.